Okay, in this video we're going to cover the 4.7 worksheet walkthrough. Alright, make sure to have your unit circle available with you. Alright, number one, we are solving, let me get closer. We are solving for the exact values. Okay, here we have the arc sine of a negative square root of 3 over 2. We need to find the answer in radians in terms of pi, so exact answers. Alright, so anytime you're looking at your ratios that are negative for sine, we should talk about quadrant 4. Remember, anytime we have arc sines or arc trig functions, we're never going to be using negative ratios in quadrant 3. Okay, so since sine is negative in quadrant 3 and 4, we never use quadrant 3. That means we have to use quadrant 4. So let's go ahead and look for our y value that equals negative square root of 3 over 4. Y value is there. This is going to be our answer. Now, you have to be careful. We are not going to use 5 pi over 3. Remember in the previous video, if we use 5 pi over 3, we're going through all of the quadrants. Our restrictions for sine is negative pi over 2 and positive pi over 2. So your value has to land somewhere in between there. Okay? So the thing I did here is I took the 5 pi over 3, subtracted one entire rotation, which gave me negative pi over 3. Another way you can look at it is that this is talking about the negative direction, so that would be our negative, and we went to 1, 2, 3 lines, and if we go up 1, 2, 3, there's my pi over 3. Okay, so you can do it either way. Part B, we have cosine. Cosine's a positive value or positive ratio here. Anytime we have positive ratio, we're always going to be in quadrant 1. Cosine is referring to our x value, so if I go here, here's my x, positive 1/2. So our answer is going to be just pi over 3. Okay. Second problem, we are going to do the exact values of arc cosine, cosine of negative pi over 4. Write our answers in radians in terms of pi. So let's go back to that one here. Now, if we look inside just the parentheses, we have a cosine of negative pi over 4. Negative pi over 4 is in quadrant 4. And cosine itself is positive in quadrant 4. So we need to use quadrant 1 because anytime a ratio is positive, then we need to translate that back into quadrant 1. Okay? So since this is negative pi over 4 here, I just want to make sure I use the positive pi over 4. So that's going to be our answer. Okay? For the second part, it says arc sine of pi over 3. So since pi over 3 is in quadrant 1, it's saying it's a positive value, then we're going to keep the same exact angle and say it's pi over 3. Okay, so sometimes it's the same, sometimes you have to switch the angle into a different quadrant. All right, number 3. These are type 1 problems. Now we're going to be drawing our triangles. So find the exact value of arctangent of 12 over. So I put arctangent 12 over 5 and set that equal to a theta. Okay. Then I go ahead and switch over the tangent and say tangent of theta is equal to 12 over 5. Tangent is y over x, opposite over adjacent. Then I can find my hypotenuse by using Pythagoras' identity. Determine that the hypotenuse is equal to 13. So what is sine of theta equal to? Sine of theta is 12 over 13. Okay. Part B, you have secant arc sine of 3/5. 3/5 is positive, so I'm going to draw it in quadrant 1. Sine is y over hypotenuse, so 3 over 5. Okay. I can solve the x distance by using Pythagoras' identity. You should get 4. And then we're trying to find secant of that angle. So remember, secant is the reciprocal of cosine. So secant is equal to hypotenuse over x, or in other words, 5 over 4. Number 4. Type 2 type problem, we have a cotangent of an arc cosine. Here, cosine is a negative value. So remember, anytime you have an arc cosine, it's equal to a theta. So I set everything equal to a theta. And then I move my cosine back over with my theta. So I have cosine theta is equal to negative 2 over 5. Which quadrant should we use for a cosine that has a negative ratio? Should be quadrant 2. Remember, we don't ever use quadrant 3. So over here, I drew my picture in quadrant 2. I used the 2 to be my adjacent, the 5 to be my hypotenuse, and then the negative went to the adjacent because that's going backwards, and the hypotenuse is always going to be positive. Okay. Once I did that, I solved for my y value, which I got to be either a plus or minus square root of 21. But I assigned it a positive 21 because we're in quadrant 2 and y is positive in quadrant 2. Okay. Then I'm going to find cotangent. If you remember, cotangent is x over y. So here I have negative 2 over square root of 21. And then I did my rationalization and I got this as my answer. Okay. The next part says find the exact value of secant arctangent of negative 5. I went ahead and set all of the stuff inside the parentheses equal to theta, because anytime you have an arc of a trig function, it's equal to theta. And then I brought my tangent back over to the other side. Remember, our ratio is negative, so we use quadrant 4 for tangent. Okay, tangent is going to be y over x, y, negative 5, x, which under here we assume to be 1, so we go ahead and put 1 there. Okay. Use Pythagoras identities to determine what our hypotenuse is. I found it to be the square root of 26. And then secant is going to be the reciprocal of cosine, or in others, hypotenuse divided by x. So the square root of 26 divided by 1, or just the square root of 26. Number 5 is a different type of problem. It's going to be type 3 problem. Here we have arc sine, then a cosine of 4 pi over 3. First thing you want to do is go ahead and evaluate what's in the parentheses. Since this is not an arc, it's asking us to evaluate. So I'm going to go to cosine of 4 pi over 3 on my unit circle. 4 pi over 3 is here. Cosine is our x value, which is 1/2. So all I did here was substitute what cosine of 4 pi over 3 is equal to, and then I have this. Okay. Next thing I'm going to do is say, okay, sine is a negative ratio. Which quadrant do we use sine as negative? When we're dealing with inverses, we're going to be using quadrant 4, which is this one over here. Then I'm going to say, where is y negative 1/2? It's going to be at 11 pi over 6. However, remember, you need to use an angle between negative pi over 2 and positive pi over 2. So the answer of 11 pi over 6 is not going to be correct. Subtract 2 pi and you'll get negative pi over 6. Or if you remember, if you're going in an up direction, it would be one line, positive pi over 6. If I go down one line, the down means negative and it's still going to be pi over 6. Okay, so either way. Next problem says arc cosine of sine 11 pi over 6. Evaluate what sine of 11 pi over 6 is. Sine is going to be our y value. So I have negative 1/2. I'm going to substitute that into the parentheses. Cosine is going to be a negative value. So cosine is negative in quadrant 2. So we're going to use quadrant 2. Okay. I'm going to look for my 1/2, my negative 1/2, which is right up here. And my theta is going to be equal to 2 pi over 3. Okay. Last problem is going to be using our calculator, so I'm going to grab that out real quick. Make sure that you are in the mode it's requiring your answers to be in. So in this particular case, it wants me to be in radians, so I make sure I'm in radians. You know that these are going to be our ratios, and what we're solving is for theta. So as long as you're in the correct mode, this should be fairly simple. Second tangent, and then you're going to do negative 2.42 and enter. It says round to the nearest hundredths means 2 decimal places. So when I'm doing the rounding, I'm going to look at the third decimal place. If this number is 5 or greater, you're going to raise this by one number. So instead of a 7, it'll be an 8. Don't forget the negative. Cosine, I'm going to go ahead and do that. So when I do arc cosine, I hope when you start entering this number, you realize that, hey, this number is greater than 1. Remember, for cosine, our range is from -1 to +1. Okay? So you shouldn't be surprised when it gives you a domain error. That means it's undefined. Last one, you're going to do second sine, 0.91. Press enter and round that to 2 decimal places. And there you go. Okay, this was a nice and short video. Let me know if you have any questions.